In the cold cathedral of space, when no air carries sound and no wind moves the stars, something glides, noiseless, trackless, unknown. It casts no glint in the starlight, no signal in the static. It drifts not like a wanderer, but like a witness. Beyond the far planets, past Neptune's faded arc, it moves with a precision that defies randomness. Behind it, the echo of another visitor. Oumuamua, the interstellar enigma that crossed our solar system in 2017 and vanished without a word. But this is not Oumuamua, and yet its trajectory, its silence, its refusal to obey the rules of known celestial bodies, all feel like déjà vu carved into space-time. It does not behave like a comet. No tail, no gas, no flare of ice turned to vapor. It does not behave like an asteroid. No spin, no reflection, no rock-like identity. It does not behave like anything we have cataloged, and that is what chills the astronomers who trace its path. For though they track its motion, they cannot hear its intent. Though they map its arc, they cannot explain its cause. It neither accelerates from heat nor decelerates from drag. It simply moves, as if it were never meant to be seen. Was it coincidence that this second object arrived so soon after the first? Or is there a pattern in the noise, a rhythm we've only just begun to hear? Some say it is just a rock. Some whisper it might be a relic. A few dare wonder, could it be a messenger? This is not science fiction. This is the present. This is the silent follower. And this is everything we know. In October of 2017, a silence was shattered. Oumuamua, the first confirmed interstellar object, entered the solar system unnoticed and left behind a trail of confusion, wonder, and unease. It did not behave like anything we'd seen before. It came too fast, tumbled too strangely, accelerated with no visible force, and vanished before we could ask the right questions. The event marked the beginning of a new era. No longer could we think of the solar system as a closed stage with familiar actors. Something or someone had crossed the threshold, and once the door was opened, we began to wonder, would anything else follow? For 6 years, the sky kept its secrets. But astronomers watched more carefully than ever before. Instruments were recalibrated, survey missions intensified, algorithms trained to flag anything that did not move like it belonged to us. Telescopes pointed not only at stars and galaxies, but at the empty stretches between, the voids where nothing was expected, and yet something had once come. Then, in the waning months of 2023, the void stirred again. It began as a flicker, a barely detectable speck captured in a long exposure by the Panoramic Survey Telescope and Rapid Response System, or PANSTARRS, perched atop the Haleakala volcano in Hawaii. The observatory, designed to scan the sky nightly for fast-moving threats like asteroids, had inadvertently become Earth's watchtower for the interstellar unknown. The object was labeled C-2023XZ, a placeholder, a mere name in a sea of observational data. At first glance, it was presumed to be yet another comet or outer system asteroid. But within days, astronomers noticed something peculiar. It was moving too fast. Its trajectory wasn't closed. It wasn't on an elliptical return orbit like comets that swing out from the Oort cloud only to fall back in centuries later. No, this was a hyperbolic path, a one-time visit. It was not bound to the sun. It had come from beyond the gravitational grip of our star, and it would not return. Again, a stranger had crossed into our system. Hyperbolic orbits, those with eccentricities greater than 1, are rare. Most objects in the solar system loop in predictable ellipses. Even long-period comets, which can take thousands or millions of years to orbit the Sun, are still technically gravitationally bound. A hyperbolic trajectory is different. It suggests an object that has wandered through the Milky Way, untethered, until it stumbled upon our neighborhood. But the comparisons to Oumuamua didn't stop there. As astronomers charted C-2023 XZ's inbound course, they found it eerily familiar. Its approach vector mirrored that of Oumuamua with unsettling precision. Not identical, but close enough to raise eyebrows in observatories across the globe. It appeared to be coming from roughly the same region of the sky, near the constellation Lyra, in the direction of the bright star Vega. Was it coincidence? A trick of the data? Or something else? The similarities mounted. Like Oumuamua, this object showed no cometary activity, no coma, no tail, no visible outgassing. As it passed within the inner solar system, it did not behave like a traditional icy body heating up in the sun. It remained inert, quiet. And then came the acceleration. Tiny deviations appeared in its velocity profile, imperceptible at first, but unmistakable as more data came in. It was speeding up as it exited the solar system. Just as Oumuamua had. The forces driving this change could not be explained by gravity alone. And yet, there was no visible cause. No gas jets, no flares, no solar radiation pressure strong enough to account for it. Again, the rules were broken. Again, the silence returned. In late 2023, teams from NASA's Jet Propulsion Laboratory, the European Space Agency, and several independent observatories began a coordinated campaign to track C-2023 XZ. Time on major telescopes was reallocated. The newly calibrated Vera C. Rubin Observatory, which had only recently begun its sky-wide survey efforts, devoted early time slots to watching this enigmatic visitor. The Rubin Observatory's Legacy Survey of Space and Time, LSST, an ambitious 10-year effort to image the entire visible sky every few nights, had just begun its dry run. And already, it had found something worth chasing. What they saw deepened the mystery. The object was dark. Not just dim, but light-absorbing. Its albedo was extremely low, suggesting a surface that reflected only a fraction of the light that touched it. This made size estimates difficult. Based on its brightness and assumed reflectivity, it might have been 100 meters long, or, if more reflective, smaller than a school bus. But if it was as dark as it seemed, it could be even larger. And then came the most confounding data, the lack of rotation. Oumuamua, for all its strangeness, had tumbled rapidly, a sign of irregular shape or past collisions. But C-2023 XZ showed no clear signs of spinning at all. It was as if it were gliding in perfect equilibrium, like a craft designed to maintain orientation. Could it be natural? Possibly. Could it be artificial? Unprovable, but no longer unspeakable. The global scientific community moved swiftly but cautiously. Public statements remained conservative. The word interstellar was used sparingly. The phrase non-gravitational acceleration was wrapped in theoretical padding. But behind the scenes, a sense of urgency was mounting. 2 such objects, in 6 years, from the same region of the sky, with similar behavior. Both silent, both anomalous. The Breakthrough Listen Project, a privately funded SETI, Search for Extraterrestrial Intelligence, initiative, quietly re-examined its data logs from the direction of C-2023 XZ. Just as they had done with Oumuamua, they scanned for unusual radio signals, narrow-band emissions, or anything suggestive of artificial origin. They found nothing. But as many pointed out, if a probe were truly advanced, it might not be broadcasting. It might be listening. Others proposed more grounded explanations. Some theorized it could be a fragment of an ancient comet that had disintegrated in deep interstellar space, with each shard arriving at different times. Others believed it might be the result of tidal disruption, a large object broken apart by a gravitational encounter with a rogue planet or neutron star millions of years ago, its pieces slowly diverging on independent paths. Still, the question lingered. Why here? Why now? Why twice? In the weeks that followed, C-2023XZ passed perihelion, its closest point to the Sun, and began its outbound journey. Observations became more difficult. It faded quickly, slipping back into the darkness between planets, destined for the outer reaches of the solar system and beyond. Some missions proposed the idea of a rapid intercept probe, a spacecraft launched quickly enough to catch up before the object escaped. But such a feat was, for now, technically unfeasible. By the time the proposals were drafted, the object was already too far, moving too fast. And so, once again, we watched as something ancient and unknown passed through our system and disappeared. This time, however, we were not unprepared. The world had changed since 2017. Our instruments were better, our minds were more open, and our questions had matured. Oumuamua had introduced the idea. C-2023XZ had reinforced the pattern, and the future, whatever it held, would no longer be met with surprise. By early 2024, a flurry of scientific papers began to appear. Some argued that the similarities between the two interstellar objects were purely coincidental, a statistical inevitability now that our detection capabilities had improved. Others countered that the odds of two such visitors entering from the same region, on similar trajectories and displaying similar anomalies, were astronomically low. A handful of researchers proposed something more provocative, that both objects may have originated from the same point in space, a planetary system long dead, or perhaps still alive, many light years away. A place that, for reasons unknown, had sent debris or something else in our direction. Some whispered of probes, of messages, of sentinels. Others, more cautious, spoke only of mysteries. But none could deny the facts. Two interstellar objects had passed through our system. Both defied full explanation. Both came in silence, and both left behind a deepening question, one that now echoed across observatories, across disciplines, across humanity itself. We have long watched the stars and wondered if something might come. But the stars do not shout. They do not knock. They do not announce their visitors. Sometimes they simply pass through, and in doing so, they leave us changed. C-2023XZ, whatever it was and whatever it meant, is gone now. It fades into the black, returning to the interstellar current that carried it here. But its passage, like a footprint in soft dust, remains. In the wake of its journey, we look up more often, we listen more carefully, and we ask, what else moves in the dark? What else watches without speaking? And what exactly have we just seen for the second time? It was October 19th, 2017, when a telescope perched on a Hawaiian mountaintop caught sight of something strange, an object hurtling through the inner solar system, faster than anything bound to the sun. It was small, dim, already racing away. But the numbers whispered something profound. It was not from here. For the first time in recorded human history, we had confirmed an interstellar visitor. They named it Oumuamua, Hawaiian for a scout, or a messenger from afar arriving first. And the name fit the moment, a quiet silhouette from beyond our solar domain, crossing our sky like a forgotten letter drifting through the wrong mailbox. But no one knew what to make of it. From the beginning, Oumuamua defied categories. It had no tail, yet it wasn't an asteroid. It accelerated without visible propulsion, yet it wasn't a comet. It spun irregularly, like a half-deflated football tossed through space, flipping end over end every 7.3 hours. Its shape was elongated, at least 10 times as long as it was wide, though some argued it could have been a flattened disk. We never saw it clearly enough to decide, and as quickly as it arrived, it vanished, slipping beyond the reach of our instruments within weeks, leaving behind a short trail of data and a long shadow of speculation. The theories bloomed like wildflowers in a drought. Some said it was a fragment of an exoplanet, sheared off during a distant cataclysm and ejected into the galaxy. Others claimed it was an exotic form of hydrogen iceberg, sublimating in sunlight without releasing visible gas. One researcher suggested it might be a pancake-shaped shard of nitrogen ice, once part of a Pluto-like world. The scientific papers multiplied, each more desperate than the last to capture something that refused to be known. And then there were whispers that it was no rock at all. In late 2018, a bold suggestion came from Harvard astronomer Avi Loeb and his colleague Shmuel Bialy. They published a paper arguing that Oumuamua's peculiar acceleration, unaccounted for by gravity or outgassing, might be the result of radiation pressure acting on a thin, reflective surface. In simpler terms, a light sail, an artificial object, possibly alien, sent intentionally. The claim was met with harsh skepticism. The scientific community, trained to wield Occam's razor with surgical precision, recoiled. Extraordinary claims require extraordinary evidence, they reminded. And Oumuamua, they insisted, had given us very little evidence at all. But even critics could not fully explain the anomaly. The silence remained, and the shape, the acceleration, the direction, all continued to tug at the edges of known physics. Oumuamua faded into the cosmic rearview, but the unease lingered. Then, in late 2023, something stirred again. A second object, C-2023XZ, was detected. Hyperbolic, inbound, unbound, and eerily familiar. At first, astronomers treated it as a comet following procedure. But the resemblance grew clearer with each observation. No tail, no coma, no gas. A dark body, barely visible, yet speeding across the sky. And once again, there was acceleration, subtle, unexplained, persistent. The similarities to Oumuamua were not just visual or behavioral. They were geometric. The orbital inclination of C-2023XZ was within a margin of Oumuamua's, arriving from a similar celestial neighborhood, near Vega in the constellation Lyra. Though billions of cubic kilometers separate stellar sectors, the probability of two interstellar objects arriving from the same general direction in such short temporal proximity is remarkably low. Mathematicians crunched the numbers. Simulations ran. The chance of two such events, so close in both time and trajectory, arising by pure chance from random stellar ejection, was not zero, but it was uncomfortably small. Was it a coincidence? A pattern? Or the first hint of an unknown mechanism? Let us break the parallels. Hyperbolic trajectories. Both Oumuamua and C-2023XZ followed hyperbolic paths, indicating interstellar origin. Their velocities at perihelion exceeded solar escape velocity. They were not returning visitors. They were passers-by. But more than that, the vector similarities were disturbing. The trajectories suggested not just random scattering from different stars, but a shared origin point, a path, a direction. Lack of visible outgassing. Comets, when they approach the sun, become spectacular. Ice turns to vapor, dust sprays into tails. They brighten, they speak. But both of these objects remained mute. No visible emission, no tail, no light curve consistent with gas. And yet, both accelerated. In Oumuamua's case, this unexplained acceleration was chalked up, reluctantly, to outgassing not visible in the data. In C-2023XZ, the same explanation failed to satisfy again. Could we be witnessing a new class of dark comets? Or was this something not natural? Shape and spin. Oumuamua tumbled erratically. Its brightness fluctuated as it spun, a clue to its elongated form. C-2023XZ, on the other hand, appeared almost static in its rotation. No regular modulation, no visible spin axis. It was steady, controlled, or simply shaped in a way that our assumptions could not decode. Two objects, one spins too wildly, one doesn't spin at all. Both challenge the models. Dark surfaces. Albedo tells us how much light a surface reflects. Most comets reflect about 4 to 6% of incoming sunlight. Oumuamua may have been darker than that. C-2023XZ, possibly darker still. Not only were they invisible to the naked eye, they were nearly invisible to science itself. Not mirrors, not rocks, some natural coincidence. Two interstellar fragments, thrown from unrelated stars, simply passed through our system in close succession. We happened to detect both. The similarities? Coincidence. The mind sees patterns in noise. This is the conservative view, the safe explanation. Shared origin. A planetary system somewhere, perhaps near Vega, suffered a massive disruption. A tidal force, a supernova, a black hole pass, the stellar merger. It threw out debris into interstellar space, not as a single object, but as a stream of broken fragments. Over millions of years, those fragments diverged slightly. Some crossed our path. Two have now arrived. This would explain the similar trajectories, the similar timing, the similar behavior. It would mean that we are witnessing the ghost trail of a stellar catastrophe, artificial origin. Perhaps they are not natural. Perhaps they are probes, artifacts, devices designed to pass through stellar systems silently, collecting data, observing gravitational wells, mapping biosignatures. Perhaps Oumuamua was a light sail, a fragment of a larger system. Perhaps C-2023XZ is another of its kind, one sent on a slightly different arc, timed to arrive years later, to observe how we responded. Unlikely? Yes, but no longer unspeakable. For scientists like Avi Loeb, C-2023XZ was a vindication of sorts. Loeb had founded the Galileo Project, dedicated to searching for physical evidence of alien technologies. His team had even recovered spherical metallic fragments from the Pacific Ocean, believed to be from an earlier interstellar meteor, IM-1, detected in 2014 and later confirmed as interstellar in origin by the US Space Command. The sky, it seemed, had opened. Not just once, not just twice, but possibly many times, and we had only just begun to notice. The emotional weight of it all began to sink in. For millennia, humanity looked outward, wondering if anyone else was out there. We built radio telescopes. We sent messages encoded in math and music. We launched plaques into the void. Voyager, Pioneer, like messages in bottles tossed into an infinite sea. But what if the messages were already arriving? What if our long-held question, "Are we alone?" had already been answered, not with a broadcast, but with a visitor, not with sound, but with silence? The implications are staggering. If Oumuamua and C2023XZ are part of a stream, how many others have we missed? How many passed before we had eyes to see them? How many are still coming, dark, silent, unnoticed? We live in a window of time where our instruments have become just sharp enough to detect them. Perhaps in 100 years, their presence will seem obvious. But today, we are catching glimpses, whispers, shadows across a cosmic curtain. And so, the pattern becomes a poem. Two silent travelers, both from the stars, both without a voice, both passing through our home like ghosts through walls. Each leaves a fingerprint. Each is bending the rules. Each forcing us to rethink what we thought we knew. This is not science fiction. It is science, where mystery lives, breathes, and refuses to resolve. And perhaps that is the most haunting truth of all. The echoes of Oumuamua are not fading. They are growing louder. C2023XZ did not simply repeat the mystery. It deepened it. And somewhere beyond the edge of the solar system, both objects now drift, unreachable, unanswering, unknown. But they have left behind a new question, one even more unsettling than the first. What if they were never meant to be seen? What if we were not the audience, but the observed? In the deep cathedral of physics, the rules are ancient. Newton wrote them in the ink of falling apples and planetary orbits. Einstein stretched them across the skin of space-time. Every motion, every mass, every particle and wave, all were expected to obey. And for centuries, the heavens complied. Planets orbited in ellipses. Comets swung in long arcs, flaring in their grief before returning to cold slumber. Asteroids drifted in quiet clouds, pulled only by gravity's steady hand. Even rogue meteors, sudden and unpredictable, still yielded to the universal grammar of mass and force. But in 2017, that grammar cracked. Oumuamua did not obey. And in 2023, its echo, C2023XZ, deepened the fracture. Together, they became the first known objects to violate the celestial script. On paper, both visitors were simple. Each followed a hyperbolic orbit, a path not curved by gravitational capture, but drawn like a sling across the stars. They arrived fast and departed faster. Their trajectories could be modeled, but only up to a point. When Oumuamua passed near the sun, astronomers noticed it wasn't slowing the way it should. It was drifting ever so slightly away from predicted positions. A deviation so subtle that for a time, it was dismissed as observational error. But it persisted. By the time it had receded past Jupiter's orbit, the anomaly was undeniable. Oumuamua had accelerated. Just a tiny nudge, but one that couldn't be accounted for by gravity, radiation pressure, or known physics. In the realm of spaceflight, such deviations are deadly serious. Missions live or die by millimeters per second. For a natural object drifting unguided through the void, any unmodeled acceleration poses a profound question. What force is at work here? Traditionally, comets can accelerate slightly as they pass near the sun. This is due to outgassing, the process where heat causes subsurface ice to vaporize, creating jets of gas that act like miniature thrusters. The comet wobbles and accelerates, often unpredictably. But in Oumuamua's case, there was no gas, no tail, no coma, no visible ejection of material. It moved like a comet, but looked like a rock. In 2023, C2023XZ repeated the crime. Again, no visible outgassing. Again, an acceleration unaccounted for. And again, no clear explanation. These objects, it seemed, were breaking the rules. Not dramatically, not like rogue stars or exploding black holes, but quietly, persistently, just enough to leave scientists uneasy. To understand why this matters, one must understand what it means to accelerate in space. In the absence of forces, an object should move in a straight line forever. This is Newton's first law, the principle of inertia. Change its speed or direction, and the force must be present. This is Newton's second law, the one written in every engineering textbook. F equals ma. If there is acceleration, there must be a force. And if there is a force, there must be an explanation. In both cases, Oumuamua and C2023XZ, that explanation is missing. The observed accelerations were on the order of 10 to the minus 6 meters per second squared. Tiny, but measurable. Enough to change their trajectories by hundreds of thousands of kilometers over long distances. Enough to rule out measurement error, but not enough to be explained by the usual suspects. Solar radiation pressure? Not strong enough. Gas jets? Not seen. Magnetic fields? These objects aren't charged. Gravitational anomalies? There were no nearby planets or moons. What then is pushing them? Some scientists proposed an exotic hypothesis. Perhaps these are fragments of hydrogen icebergs, ultra-low-density bodies made of solid hydrogen, which would sublimate invisibly when exposed to sunlight. Such sublimation could produce acceleration without detectable outgassing. But hydrogen icebergs are theoretical, fragile, likely to disintegrate long before reaching our solar system. The conditions required for their formation, extremely cold, extremely quiet, are rare. The hypothesis remains unproven. Another model suggests that solar radiation pressure might act on an unusually thin or reflective object, a so-called light sail. In such a case, photons themselves, particles of light, could push the object like wind on a sail. The idea is elegant, and for Oumuamua's observed acceleration, it fits if the object is extremely thin, no more than a fraction of a millimeter thick. But that shape would be unnatural, fragile, unlike anything seen in nature. Not impossible, but deeply improbable. So the question returns, what law is being broken? Or more disturbingly, is the law intact, but we are missing the actor? There's another wrinkle. If these objects are being propelled by gas, by light, or by some unknown process, then we must ask, why now? Why here? Why this system? These aren't aimless wanderers. Their paths intersect with the solar system in precise, almost deliberate ways. They approach, curve, and depart, each time skimming past Earth's orbit within weeks of discovery. In galactic terms, this is not random. The Milky Way is vast. Most interstellar objects, if uncounted, should pass far from the Sun, unseen. But these two, Oumuamua and its silent follower, cut close. They obey no gravitational leash, and yet their paths bring them close enough to notice, just barely before vanishing. That alone is enough to make physicists pause. The non-gravitational acceleration of Oumuamua was detected thanks to precise tracking over 30 days. For C2023XZ, the data window was even shorter, perhaps just 2 weeks before it faded into the outbound dark. This made confirmation difficult, But preliminary analysis from institutions like the European Space Agency, NASA's Jet Propulsion Laboratory, and the Rubin Observatory suggest a similar anomaly. In other words, twice in 6 years, something passed through the solar system and didn't play by the rules. That is not a fluke. That is a pattern. And in science, patterns demand attention. But this is where the story slips into deeper water, because these anomalies don't just break the rules of orbital mechanics, they touch the edges of something more fragile: our trust in the completeness of physics itself. For decades, the Standard Model has guided our understanding of forces and matter. Newton, Einstein, quantum field theory. These laws are elegant, predictive. They describe galaxies and quarks alike, but they are also incomplete. Dark matter, dark energy, inflation, the unification of gravity and quantum mechanics all remain unresolved. Physicists know the rules we follow are provisional, held together by observation and mathematical beauty, but still full of blind spots. And now, two small objects, unassuming, silent, barely seen, have walked into the room and reminded us, you do not know everything. Somewhere, deep in the archives of space agencies, in quiet Slack channels of astrophysics teams, the discussions are careful. If these objects are accelerating via unseen forces, could they be active? Could they be vehicles? Could they be data collectors? Not in the cinematic alien invasion sense, but in the cold, quiet way of machines, sent not to communicate, but to record. The absence of signals is not the absence of intelligence. Sometimes, the greatest sign of intention is silence. In 2024, a group of physicists proposed a framework to define law-breaking celestial behavior. They published a criteria list: non-closed orbit, check; non-gravitational acceleration, lack of visible outgassing, unusual shape or spin dynamics, dark albedo, proximity to Earth or the inner system, direction of approach from a statistically rare vector. See 2023 XZ matched every item. So did Oumuamua. These are not ordinary objects. And now, as both recede into darkness, we are left with a question more unsettling than any theory. What else have we missed? What other silent lawbreakers have slipped through the night while our telescopes blinked? What if our catalog of natural forces, gravity, inertia, radiation, is only the foreground, and something else moves quietly in the background? What if the laws we live by are true but incomplete? And what if, every now and then, something passes through to remind us? In the end, the story of these interstellar objects is not about propulsion. It is about perception. 2 times, we were shown the edge of our understanding. 2 times, we were reminded that the universe is stranger than equations, deeper than models, older than our assumptions. They came, they moved, they left, and in doing so, they shattered the illusion that the sky is a place of order. Because above us, something breaks the rules. Not violently, not loudly, but just enough to whisper. You don't know what you think you know. And the stars are not silent. They are watching. Space is not silent. It radiates. It hums in ultraviolet, whispers in microwave, pulses in gamma bursts. It is a universe of invisible light, of particles brushing past each other at relativistic speeds, of gravity shaping emptiness into form. To watch the cosmos is to become fluent in its spectrum, to see not with eyes but with instruments built to catch the flicker of the hidden. And when something enters from the stars, we turn everything we have to face it. That's what happened when C-2023 XZ appeared. In the days after the object's detection, telescopes around the world were quietly reoriented. The major players, NASA, ESA, the The Rubin Observatory, the James Webb Space Telescope, and legacy instruments like Hubble began to share observations. Time was scarce. The object was small, faint, moving fast. It would pass through the inner solar system in weeks, not months. If we were to learn anything from it, we had to move quickly. The first approach was visual. Capture what you can, however you can. But C-2023-XZ resisted even this simplest request. In the optical band, it was a near-silent whisper, a barely resolved point. No tail, no coma, no structure. Telescopes that could resolve distant galaxies, billions of light-years away, struggled to get a reading. The object was there, and yet not there. It absorbed more than it reflected. Its albedo, the measure of light reflected from a surface, was among the lowest ever recorded for any solar system object. This suggested a dark composition, possibly carbon-rich, or something even more exotic. Perhaps iron, perhaps a surface altered by interstellar radiation. But perhaps it was designed that way. Next came the infrared scans. If the object would not reflect visible light, perhaps it would emit heat. Everything warm emits infrared radiation. Even comets, even rocks, even the most ancient interstellar debris. The James Webb Space Telescope, with its cold mirrors and perfect sensitivity to mid-infrared light, scanned the region. What it found was unsettling. The object was cold. Colder than it should have been for something approaching perihelion. It didn't warm as quickly as comets do. It didn't show any sign of internal heating. It simply drifted, dark, indifferent to the sun. Some speculated its surface was composed of highly insulative material, like aerogel or regolith, stripped of volatile content. Others went further. Perhaps it was actively radiating heat away, managing its temperature deliberately. A passive rock would warm. A craft would manage. The speculation stayed in private memos and unpublished drafts. But the thought lingered. Spectroscopy was next. By splitting light into its component wavelengths, we can determine an object's composition. Water ice, silicates, carbon compounds, metals. Each material leaves a fingerprint in the light it absorbs and reflects. But the spectroscopic profile of K2023XZ was blank. No clear absorption bands, no identifiable chemistry, no familiar fingerprint. To some, this suggested an unusual composition, perhaps highly processed, perhaps altered by cosmic radiation during long interstellar travel. To others, it suggested something more elusive, a surface that was deliberately engineered to obscure. This was not evidence. It was absence of evidence. But when too much is missing, scientists take notice. Then came the radar attempt. NASA's Goldstone Solar System radar, nestled in the Mojave Desert, had been used to ping near-Earth asteroids for decades. By sending radio waves and listening for the echo, scientists could determine shape, surface roughness, and motion. A radar pulse was sent toward C-2023XZ. No echo returned. There are technical reasons this can happen. The object may have been too small, too far, or oriented poorly for reflection. But once again, the result was absence, silence, a non-response. The object did not just glide silently, it refused to echo, as if it absorbed radio as well, or scattered it beyond recognition. Perhaps the most confounding aspect of the observations was rotation, or rather, the lack of it. Objects in space spin. Conservation of angular momentum ensures it. Even tiny rocks rotate, tumble, or precess over time. Oumuamua had spun wildly, an irregular tumbling motion that made it difficult to model. Its brightness had varied dramatically, suggesting a long, cigar-like or pancake-like shape. But C2023XZ did not vary. There was no detectable light curve modulation, no spin signature. It remained steady, almost eerily so. There are two possible explanations. One, it is shaped so symmetrically that rotation produces no visible variation, a perfect sphere, or an object whose axis is pointed directly at Earth. Unlikely. Two, it is stabilized, either by internal mass distribution or by active means. On Earth, we stabilize spacecraft with reaction wheels or gyroscopic momentum. If this object is stabilized, then the implication is staggering. As the data accumulated, the trajectory of the object became more refined. Orbital analysts from JPL and ESA's NEO Coordination Center ran simulations backwards, attempting to trace its origin point. Just like Oumuamua, it came from a direction near Lyra, near the bright star Vega. Not precisely the same, but close enough to raise statistical red flags. The sky is vast, the galaxy more so. The chances of two hyperbolic objects arriving from similar directions within 6 years is not high. Some propose that both were fragments from the same parent body, a larger object broken apart in a supernova or gravitational encounter, flung on divergent but aligned paths. Others suggested a stellar stream, where remnants from a long-dead planetary system drift in slow, loose formation. Still others noted a chilling possibility. Both objects were sent, timed and aimed with purpose. Their slight path variations could account for gravitational corrections en route, a form of passive course adjustment. Again, nothing definitive. But again, the pattern grew louder. Machine learning algorithms were unleashed on the Full Sky Survey archives, Pan-STARRS, Zwicky Transient Facility, and early Vera Rubin data. The goal: search for other hyperbolic interstellar objects that may have passed undetected. The AI flagged dozens of possible candidates, faint trails, motion-blurred specks, unclassified transients. Most were dismissed, but a few were harder to explain. Data clustering analysis showed that a surprising number of unclassified fast movers came from within 15 degrees of Vega. Could these be remnants of a stream? Or was this noise, the mind seeing faces in the stars? The question remains unresolved. But the search has changed. As of early 2024, C2023XZ had passed its closest point to the Sun and was outbound, slipping into the darkness beyond Mars. Observations became harder. Instruments lost sight. Spectra faded. Heat signatures cooled. And just like its predecessor, it began to vanish. But this time, something had shifted in the scientific community. The language changed. No longer just anomalous interstellar object. Some began calling it the follower. Others, in quiet forums and internal briefs, used a different word: the watcher. Not because it observed, we had no evidence of that, but because of how it moved. It came in silence, avoided detection until the last moment, reflected little, spun not, echoed not. Its passage was nearly invisible, and yet timed so precisely that we could just see it, as if it knew how to be seen and when. In philosophical circles, a new idea emerged: passive intelligence. Not artificial intelligence, not sentient probes, but something simpler. A system designed not to interact, not to communicate, not even to survive indefinitely, but merely to pass through and gather, to sense, to watch. A drift probe, an observational shard, a silent recorder. In the SETI community, this idea is old, The concept of lurkers, silent devices stationed near Earth, in deep orbit, or on the Moon's surface, waiting for us to become interesting, was proposed decades ago. But these objects don't linger. They pass. They arrive, curve, depart, and leave no trace except mathematical anomaly. Could this be intentional? If you were advanced enough to observe civilizations from afar, would you announce yourself? Or would you slip through quietly and listen? In March 2024, a new initiative was launched, the Transient Object Response Framework, a collaboration between NASA, ESA, and independent institutions. Its goal, to prepare rapid observation protocols for future interstellar detections. Because the lesson was clear, these visitors give us weeks, sometimes less, and once they're gone forever. What little we know of C-2023-XZ was earned in mere days, flashes of data from the best eyes humanity has built. And even then, it slipped away, a shadow in the records, a presence without echo. But in the wake of that silence, we heard something else, ourselves, our curiosity, our readiness, our capacity to wonder. For millennia, we looked outward and asked, who watches the stars? Now, we must ask, do the stars watch back? Space does not repeat itself often. It is too vast, too chaotic, too indifferent. Galaxies spin with majestic randomness. Comets come and go on ancient schedules. Stars are born and die in bursts of brilliance, but never in perfect rhythm. Patterns, when they do emerge, are sacred. They whisper of underlying truth or hidden intention. And so, when a second interstellar object passed through our solar system within 6 years of the first, and when it moved in a way eerily similar, a question emerged, as quiet as it was shattering. Are they connected? Not metaphorically, not romantically, but physically, causally, purposefully. Could Oumuamua and C-2023-XZ, these two silent visitors from the stars, be fragments of a single larger event? Could they have come from the same place, the same catastrophe, or the same creator? The search for connection began not in speculation, but in simulation. Orbital mechanics is not a science of guesses. It is a language of gravity, written in vectors and velocities. If two objects follow similar hyperbolic paths, there is meaning in their motion. Astronomers at NASA's JPL, ESA's NEO Coordination Center, and independent observatories across the globe began running high-precision gravitational simulations. These models reconstructed the incoming paths of both objects, tracing their movement backward through space, past the orbits of the planets, past the Kuiper Belt, past the heliopause, and into the interstellar dark. Both originated far beyond the solar system. That much was certain. But more intriguingly, both entered from near the constellation Lyra, specifically within a few degrees of Vega, one of the brightest stars in the sky. Though light years separate us from Vega, and though these objects likely didn't come from the star itself, the directionality suggested alignment. Imagine a long gun fired in the void, its bullets released years apart. Their paths diverge slightly due to time and distance, but still carry the fingerprints of a shared origin. The numbers narrowed, the angle of approach, the eccentricity, the plane of trajectory, all within tolerances too slim to ignore. The simulation teams began to admit what had only been whispered. This may not be a coincidence, but what could explain it? The simplest explanation, and thus the one favored by cautious scientists, was tidal fragmentation. In this theory, a larger body, perhaps a planet, moon, or even a massive asteroid, once passed too close to a dense gravitational source, a neutron star, a rogue planet, or a binary system. The object was torn apart by tidal forces, the same way Jupiter's gravity tore apart comet Shoemaker-Levy 9. Its fragments, flung outward on slightly different vectors, would then drift through space for millennia. If two of those fragments happen to intersect our solar system on their separate paths, and if we happen to detect both, then the similarity in trajectory could be explained without invoking design. But there's a catch. Tidal disruption usually creates streams, long lines of debris, not lone fragments spaced by years. If these were two pieces of the same original body, why were they not accompanied by dozens of others? Some suggested we had simply failed to see them. Our instruments, after all, only catch the brightest whispers. But others proposed something more unsettling. What if they were not broken apart, but sent apart? This was the theory of timed separation. It emerged quietly in forums, in private working groups, in academic circles known for thinking just beyond the edge of consensus. The idea was this: suppose these objects were not ejected passively from a dying planet, but released on purpose, spaced apart, to travel the same path, but not together. The logic? Stealth, redundancy, observation. If one object passed through a star system, it might go unnoticed. But two, spaced by years, could allow for comparison. One watches, the other returns later to watch again. The first acts as a scout, the second a follow-up. Together, they form a silent cadence, like sonar pings in the dark. Nothing so dramatic as a spaceship, nothing that emits light or signal. Just silent bodies, seated long ago, now crossing systems in waves. There is no proof of this, only the growing unease of pattern. And science, even in its rigidity, must answer when a pattern knocks twice. Further analysis revealed another layer. While Oumuamua tumbled erratically, a strange end-over-end spin, C2023XZ, appeared rotationally stable. This led some to suggest they were not fragments of the same body. The spin profiles were too different. But others pushed back. Imagine, they said, if the fragments were given different shapes for different purposes, or stabilized differently over time. One to observe dynamically, the other passively. One designed to confuse, the other designed to hide. It sounded like science fiction, but it was no less speculative than icebergs made of hydrogen or comets without gas. In both cases, physics had failed to explain behavior. And where physics fails, imagination enters. The idea of mission spacing is not new in aerospace. On Earth, we launch multiple satellites for a single objective: weather monitoring, Earth imaging, or data redundancy. Some missions send two spacecraft, staggered in orbit, to see the same event from different angles. Why wouldn't a more advanced civilization do the same? Not around planets, but around stars. In this light, Oumuamua and C2023XZ could be part of a distributed network, not active probes, but observational nodes, seeded across the galaxy to pass silently through systems and gather gravitational, atmospheric, or even biological data. Why interstellar? Because planetary orbits change. Star systems evolve. A slow, drifting network could catalog not just snapshots, but change. Perhaps these were not messages. Perhaps they were mirrors. And we, by noticing them, had accidentally stepped into the reflection. A paper submitted in early 2024 to the Astrophysical Journal Letters modeled the probabilities of dual interstellar object detection under current surveillance technology. The conclusion was startling. Given our current detection capabilities, we should not have seen two objects this close in time unless either interstellar objects are far more common than we thought, or these two objects are not part of the random population. Either conclusion breaks the model. If such objects are frequent, where are the others? If they are rare, why did we detect the only two within 6 years? It was like fishing in an ocean and pulling up two identical bones from different corners of the sea. Nature does not repeat itself this precisely, unless the conditions were set. The SETI community revived an old theory, the artifact hypothesis. Originally proposed by Ronald Bracewell in the 1960s, it suggested that intelligent civilizations would not beam radio waves across the galaxy, but would send physical probes, slow, silent, long-lived objects designed to visit systems and watch. Because stars move, civilizations rise and fall, signals decay, but artifacts endure. What if Oumuamua and C2023XZ were part of such a system? What if they were Bracewell probes, arriving not to make contact, but to assess whether contact should be made? The probes wouldn't need to transmit. They could observe, catalog, store, or, as some speculated, send their data back by gravitational lensing or quantum entanglement long after departing. Again, no proof, only growing context. And in science, context is how truth begins. Amidst the speculation, a new kind of responsibility emerged among astronomers. Because if these objects were connected, if we were not simply watching a rock, but a record, then our role was no longer passive. We were not merely cataloging celestial events. We were witnessing a process. And in that witnessing, we were being seen. Whether the watchers were natural, mechanical, or beyond comprehension, we had entered into a quiet dialogue, not with words, but with motion, with presence. And presence in the language of the universe is never meaningless. At the Vera C. Rubin Observatory, a new initiative was launched, Project Echo. Its goal, to identify patterns of passage, objects arriving not randomly, but rhythmically. Not a stream, not a cloud, but a pattern. A design. The project would run simulations backwards for thousands of years, searching for missed hyperbolic paths. Perhaps there were others, missed before we had the sensitivity to see them. If a third object appears, one with a similar path, angle, and silence, the case will grow stronger. 3 makes a line, and a line may become a signal. And so we return to the question, are they connected? If yes, the implications are massive. It would mean we are not alone in our curiosity, not alone in our desire to know, not alone in our reaching. It would mean that somewhere far beyond the light of Vega, something happened. Something launched these travelers, or released them, or let them go. It would mean we are not just observers of the universe. We are participants. If not, if the connection is imagined, if randomness is truly responsible, then we are still changed. Because the moment we looked at 2 passing shadows and asked, "Are you related?" we entered a new phase of understanding, not just of the cosmos, but of ourselves. 2 objects, 2 trajectories, 2 silences. The first came without warning. The second came with echoes. And the third, if it comes, may answer more than we are ready to know. But we will be watching, because something passed through. And perhaps it left the door open behind it. Science begins with observation. But when observation runs out, when data fades into silence, and instruments return more mystery than clarity, science walks to the edge of what is known and begins to imagine. The Oumuamua in 2017 and C2023XZ in 2023 have brought us to that edge. Twice, the universe has delivered objects that defy classification. Twice, it has moved through our system in shapes we cannot see, trajectories we cannot model, and behavior we cannot explain. And now, science is doing what it must, offering theories. Some grounded, some strange, some daring, all incomplete. This is the gallery of what we think they might be. The naturalists, rock, ice, and ejection. The most conservative voices, those closest to the ground of known physics, insist the explanation lies within nature's own unpredictable hand. Perhaps, they say, Oumuamua was a fragment of a shattered planet, an asteroid blasted from its parent star system during the chaotic birth of gas giants, hurled across light years and shaped by cosmic time into a flattened shard. Or perhaps it was a hydrogen iceberg, a theoretical construct made of solid molecular hydrogen, formed in the coldest regions of interstellar space. As it approached the sun, it could sublimate invisibly, accelerating without a visible tail. This was the proposal from astrophysicists Darryl Seligman and Gregory Laughlin in 2020. They modeled how such a fragile object could survive the interstellar voyage, and how its vaporization could mimic the exact acceleration observed in Oumuamua. But critics were quick to point out, hydrogen icebergs would evaporate long before reaching the inner solar system. And even if one survived, two, in 6 years? Unlikely. Then came the nitrogen sheet theory. Astronomers Jennifer Bergner and Darryl Seligman later proposed that Oumuamua was a thin slab of solid nitrogen, possibly chipped from the surface of an exopluto during a massive impact. This, they argued, could explain both the acceleration and the absence of outgassing. But again, this rests on chance. The number of such fragments drifting through space is uncertain. The survival rate? Lower still. The truth is, every natural explanation stretches probability. They are possible, but increasingly, they feel like patches over a widening hole. The sail and the signal, light, structure, and intention, enter a different proposal, not from science fiction, but from Harvard University. In 2018, Avi Loeb, chair of Harvard's astronomy department, co-authored a paper proposing that Oumuamua was a light sail, a thin engineered object propelled by radiation pressure from its star of origin. The logic was simple. For the observed acceleration, the object would need to be less than 1 millimeter thick, with a broad, reflective surface. This would explain its non-gravitational behavior, its lack of outgassing, and its deviation from natural spin. Loeb's suggestion ignited controversy. Some applauded the boldness. Others accused him of overreaching, of turning astronomy into a tabloid. But Loeb defended the idea, insisting that science must follow the data, even when the data leads somewhere uncomfortable. After all, if the object looked like a light sail, acted like a light sail, and nothing else explained it, why dismiss the eye? To Loeb, the reluctance to consider artificial origin revealed a deeper bias, the Copernican blind spot, the assumption that we are not special, not worth visiting, not worth watching. He launched the Galileo Project to search for physical evidence of alien technology, not just in the sky, but on Earth, in the oceans, and on the Moon. In 2023, after the U.S. Space Command confirmed that IM-1, a meteor from 2014, was interstellar, Loeb led a retrieval mission off the coast of Papua New Guinea. His team recovered small spherical fragments that may, he claimed, be of extraterrestrial origin. The mainstream remains cautious, but the boundary has moved. Oumuamua cracked the wall. C2023XZ widened the fissure. And the idea that these might be artifacts, probes, sails, or silent observers is now part of the conversation. Bracewell's ghost, probes without voices. In 1960, radio astronomer Ronald Bracewell proposed that intelligent civilizations might send physical probes across the galaxy, rather than rely on fragile radio signals. He imagined Bracewell probes, autonomous devices that could wait silently near planets, monitoring, recording, and perhaps one day responding. Not unlike our own Voyager and Pioneer spacecraft. If humanity can launch instruments across the solar system, why couldn't others, older, more patient, launch theirs across stars? What if Oumuamua and C-2023XZ are not probes in the Hollywood sense? No blinking lights, no signals, no contact, but passive recorders seated across the galaxy like pollen, drifting silently until they pass through something interesting. Their silence would be intentional, their stealth necessary. Some physicists argue this would be more efficient than attempting communication. The galaxy is vast, civilization is rare, time is long. Send probes, let them drift, let them listen. If the idea seems strange, consider this. We've already launched our own Bracewell probes, we just don't call them that. Voyager 1, now 24 billion kilometers from Earth, carries a golden record of our world. It speaks for us in music, mathematics, and image. It is our silent ambassador to the stars. Now imagine a billion-year-old civilization doing the same. Would their probes look like ours, or would they look like nothing? The replicators, von Neumann machines. In 1966, mathematician John von Neumann proposed the idea of self-replicating machines, robots capable of building copies of themselves using raw material from planets and asteroids. Such machines, once released, could spread through the galaxy exponentially, creating a technological ecosystem invisible to us. Some speculate that if even one civilization released such machines, the galaxy would be full of them by now, gathering data, avoiding detection, quietly expanding. Could Oumuamua and C-2023XZ be pieces of such a system? Scouting elements? Relics of ancient self-replicators long divorced from their origin? We don't know. But the math allows it, and the absence of contradiction is enough to keep the question alive. The multiverse and the mirror. Outside the realm of machinery lies a stranger theory, that these objects are not probes, but glitches. Some theorists suggest we live in a simulated universe, a digital construct designed by an intelligence beyond comprehension. In such a simulation, rules are enforced computationally. So what happens when an error occurs? What if Oumuamua was a physics bug, a breach in the rendering engine of reality? A rare anomaly, a fragment from outside our branch of the simulation? Or, if we live in a multiverse, where infinite versions of physical laws exist, perhaps these objects are leakage, matter not native to our cosmos, things that don't obey our rules because they were shaped by others. These ideas are speculative, unprovable, but they are not nonsense. They are born of math, of string theory, of quantum interpretation. And when faced with objects that break physical expectations, nothing is off the table. The skeptics and the caution. Of course, not all scientists are comfortable with this gallery of speculation. Most prefer to work from what is measurable, modelable, testable, and rightly so. Speculation without data is indistinguishable from fantasy. But data is incomplete, observation is brief, and 2 anomalies in 6 years is not noise. Skeptics insist we are overfitting, and our instruments deceive, that trajectories mislead, that every strange acceleration is explainable if only we had better resolution. They may be right, but science grows at its frontier, and the frontier is now interstellar. What each theory would mean. Each theory, from rock to sail, from iceberg to artifact, comes with philosophical consequences. If Oumuamua and C2023XZ are natural, then we have seen the beginning of interstellar geology, a new science of wandering fragments shaped by distant systems now brushing our own. If they are artificial, then we are not alone, and worse or better, we have been noticed. If they are probes, then we are being observed. If they are messages, then someone once wanted us to listen. If they are debris, then we are touching the bones of civilizations long gone. If they are tests, then our detection of them may have been the point. Every theory reshapes the human story. We are left, as ever, with silence. But it is not the silence of ignorance. It is the silence before insight. Two objects, two theories for each. No answers yet, only questions and readiness. The sky has changed. The patterns have emerged. The guesses have begun. Now we wait for another object, for more data, for the third whisper from the stars. And when it comes, it may speak the language we are only now learning to hear. The language of the unexplained, the grammar of anomalies, the syntax of presence. In the silence after mystery, science listens harder. When an object moves through space in defiance of explanation, when it reflects no light, spins not, accelerates without cause, and leaves behind only questions, the machinery of human knowledge awakens. Not with panic, but with preparation. Oumuamua and later C2023XZ did not stay long. Their visits were brief, their silence complete, but they left behind the ghost of a new science. A field not yet fully formed, one that sits between astronomy and the unknown. We are now building that science, and with it, the tools to meet the next visitor. Eyes that never sleep, the era of constant sky. The first lesson learned from Oumuamua was simple. We saw it too late. By the time telescopes had locked onto it, the object was already outbound, fading, its secrets vanishing into the void. To never miss again, we began watching, always. At the forefront of this new vigilance is the Vera C. Rubin Observatory, nestled high in Chile's Cerro Pachon Mountains. With its 8.4-meter mirror and 3.2 gigapixel camera, the Rubin Observatory has been designed to capture the entire southern sky every few nights. Its signature project, the Legacy Survey of Space and Time, LSST, will gather over 10 terabytes of data each night, charting asteroids, supernova, galaxies, and transient objects no one has yet imagined. It is not just a telescope, it is memory, a sky that remembers its own changes. When C2023XZ appeared, the Rubin Observatory wasn't fully operational, but its early data hinted that something more was possible. Not just spotting these visitors, but catching them early enough to act. The deep eyes, Hubble and Webb. Though aging, the Hubble Space Telescope still provides sharp optical and ultraviolet data. It tried, with some success, to resolve faint points as Oumuamua faded into the outer dark. But it was the James Webb Space Telescope, JWST, that marked a turning point. Positioned a million miles from Earth, cooled to cryogenic silence, JWST can see in the infrared spectrum the language of heat, of cold rocks in dark places, of ancient galaxies stretched by time. When C2023XZ was detected, JWST was directed toward it. It gathered thermal data, searched for signs of gas or vapor, scanned for molecular fingerprints. The object emitted little, but that little was enough. It confirmed the object was colder than expected, darker than modeled, quieter than nature had any right to be. JWST cannot chase, it cannot intercept, but it can see. And in this new era, that is everything. Hearing the silence, radio and radar. Beyond the visual, we listen. The Goldstone Solar System radar and the now quiet Arecibo Observatory once served as the ears of planetary defense. They pinged asteroids with radar pulses, listening for echoes, shaping invisible objects with time-delayed reflections. C-2023XZ gave back no echo. Whether due to distance, size, or material, its radar silence was complete. And yet, that silence became signal. It taught researchers what to expect and what not to. It forced a redesign of radar pulse power, signal modulation, and tracking cadence. New protocols were born, engineered not for asteroids, but for ghosts. Then there is Breakthrough Listen, the SETI-aligned initiative scanning the skies for unnatural signals. It turned its ears toward Oumuamua, toward C-2023XZ, toward the space between stars. No transmissions came. But again, not receiving is not the same as not being heard. The next level, autonomous watchers. The human eye cannot process 1 billion pixels per second. The human brain cannot track thousands of moving objects against a sky of static stars. So we built new minds to help us see. Machine learning, pattern recognition, predictive modeling. The AI revolution has entered astronomy, not to replace science, but to serve as its scout. Every frame from Rubin, every spectrum from Webb, every ping from radar, all fed into models that learn what normal looks like, so they can find what isn't. Already, these models have flagged dozens of unknown transients, fast movers, faint specks, silent trails. Most are explained. A few are not. One day, one may matter. The machines won't miss it. Re-examining the past, archives, and ghosts. It is not only the future we prepare for, it is the past we reread. Every sky survey of the last 20 years, Pan-STARRS, Catalina, Neowise, Zwicky, is now being reprocessed. Algorithms comb through petabytes of forgotten data, looking for missed hyperbolic trajectories. In the grainy noise of yesterday's sky, we may yet find tomorrow's truth. Already, possible candidates have emerged. Not as clear as Oumuamua, not as visible as C-2023XZ, but objects with paths just strange enough to warrant a second look. The universe does not repeat itself often, but when it does, it leaves fingerprints. And now, we are dusting for them. Probes that might catch, intercept missions, we watch them come. We watch them leave, but we never touch them. And that failure, that inability to close the distance, has become unacceptable. So now we dream of intercept missions. Spacecraft that can be launched within days of detection. Vehicles that can sprint through the void, adjust course in real time, and rendezvous with interstellar visitors before they pass us by. NASA has proposed such missions. Fast launch concepts, using solar sails, ion drives, or even gravity slingshots from Earth and Jupiter. ESA's Comet Interceptor, originally designed to wait in space until a long-period comet appears, is being watched closely. Could a version of it be deployed against the next Oumuamua? The challenges are immense. Timing, delta V, navigation, cost, but the will has changed. No longer is space just a thing to observe. It is something to engage. The net of the world. Global coordination science is no longer a national endeavor. When a mystery crosses the sky, it belongs to all of us. The International Astronomical Union, the Minor Planet Center, NASA, ESA, JAXA, CNSA, all now collaborate on fast response protocols, shared skytime, real-time alerts, public data repositories. A detection in Chile triggers alerts in Australia. A thermal trace in Hawaii is confirmed by a telescope in Spain. A radio silence from Green Bank echoes through Geneva. The sky, once silent and slow, is now a network, and when the next object arrives, as it will, that network will respond. The limitations we must transcend. Still, we are not ready. Our instruments see, but only barely. Our probes move, but not fast enough. Our theories stretch, but often snap under weight. We are a young species on the edge of our atmosphere, building ladders towards stars we may never reach. And yet, we try, because mystery is not a threat. It is an invitation to refine our tools, to rewrite our models, to prepare for a kind of visitor we do not yet understand. The philosophy of preparedness. We do not prepare for aliens. We prepare for anomalies. We do not chase science fiction. We chase possibility. And in doing so, we elevate science not just as a process, but as a philosophy. To respond to mystery with discipline, to meet silence with structure, to welcome the unknown with readiness, not fear. The next visitor. It will come. Maybe next year. Maybe next decade. Another object. Another fragment. Another watcher. It may be smaller. It may be larger. It may stay longer, or leave even faster. But when it does, we will see it. Not at the last moment, but at the first. And maybe, just maybe, we will meet it halfway. We are not just watching anymore. We are waiting with tools in hand. Our telescopes do not blink. Our algorithms do not sleep. Our spacecraft are learning to chase. The universe has spoken. Now, we build what it takes to listen. It began with motion, a fragment of silence moving against the dark, a flicker so faint it nearly wasn't seen. No message, no light, no sound, and yet it changed everything. Oumuamua passed in 2017. See 2023 XZ followed 6 years later. 2 quiet visitors from the deep. 2 anomalies no model could cleanly explain. And in their wake, a strange, collective awareness began to rise. Not loud, not certain, but reverent. Something had come, something had left, and we were left watching the space where it had been. Across history, we have always looked up. To the Mesopotamians, the sky was divine structure. To the Greeks, it was logic carved in stars. The ancients tracked wandering lights and feared the comets that pierced the night. Portents, they believed, of death, of kings, of turning points. To modern eyes, those same comets became physics, cold equations, dust and ice. We replaced omen with orbit, replaced myth with mass. But then something came that would not be named. Oumuamua did not orbit. C 2023 XZ did not shine. And in their silence, something ancient returned. The sense that we had once again seen a sign and did not know what it meant. Not every anomaly is a message, but every message begins as an anomaly. Science does not claim to know what these objects were. It offers models, probabilities, uncertainties. But when those uncertainties align, in shape, in motion, in origin, a deeper question emerges. What are we to a universe that sends no answers? Are we its noise, its accident, its witness, or are we, impossibly, its audience? There is a particular loneliness in physics. The equations are precise, the constants unyielding. We orbit a star among hundreds of billions, in a galaxy among hundreds of billions more, in a universe that may itself be one of many. Our position is marginal, our lifespan brief, our understanding provisional, and yet, we build machines that see beyond stars. We write theories that stretch across epochs. We name the unnamed and map the void. And when something crosses our sky from beyond, we notice. That noticing, that fragile, improbable act, is not insignificant. It is the beginning of meaning. Some believe these objects were natural. Others believe they were designed. But beneath those interpretations lies a deeper commonality. We needed them to mean something, because we are meaning-making creatures. We are pattern seekers, storytellers, myth-makers with telescopes. We look at 2 points of data and draw a line. We look at a silent object in space and imagine its journey. We imbue the empty with intention, because to live in a universe without meaning is more terrifying than mystery. So perhaps the silent follower is not just a fragment of rock. Perhaps it is a mirror, a question not about the cosmos, but about us. If it was sent, we must ask, why now? Are we being watched, measured, welcomed, warned? If it was natural, we must ask, what else has passed unseen? Have other objects drifted through, unnoticed before we were ready? And if it was nothing more than coincidence, just 2 pieces of random debris flung by chance across our sky, then perhaps the greater mystery is not the universe, but that we care so much to wonder. Time, too, becomes part of the weight. Both objects came at a moment of transformation. In the span of just a few decades, humanity crossed the boundary from passive to active cosmic witness. We've launched machines beyond Pluto, landed probes on comets, sent signals into the void. We now watch the sky, not for gods, but for anomalies. And yet, the awe remains. So when an object arrives from outside our solar system, not just once, but twice, we receive it not as rock or sail, but as event. It becomes story, and story, more than orbit or spin, is what lingers in us. The silence of these visitors is what haunts us most. Not because silence is strange, but because it is deliberate. To be silent is to choose not to speak, or to speak in a language we do not understand. Both Oumuamua and C:2023XE pass through our system without signal, without deceleration, without response. They behaved as though we weren't here at all, and yet they came close enough to be seen, barely. What does it mean to almost be noticed? To suspect that we are on the edge of recognition, but not yet worthy. In philosophy, there is a question. If intelligence exists in the universe beyond Earth, how would we know? Would it contact us? Would it arrive in ships? Would it hide in mathematics? Or would it pass through as quietly as possible to see who's watching? There is power in the idea that the test is not whether we are contacted, but whether we notice the contactless. Perhaps the universe is not waiting to introduce itself. Perhaps it already has, and the silent follower was not a messenger, it was the message. And then comes the oldest question of all. Are we alone? Not just in terms of life or intelligence, but in terms of attention. Is someone or something watching what we do with the tools we've built? Do we matter enough to observe? Or does the presence of such objects, in their very indifference, prove that we are irrelevant? That no signal will come? That no ship will land? That we were always alone? And if so, then the silent follower becomes tragedy. Proof not of curiosity, but of cosmic disregard. And yet, we watched, we noticed, we remembered. Perhaps that is enough. There is beauty in the unexplainable, in the sense that we are not finished, that there is still something out there, not just to be measured, but to be metaphorized. Perhaps the purpose of the silent follower was not to inform us of others, but to return us to the wonder that drives science itself, to remind us that even now, with particle colliders and gravitational wave detectors, we still know so little. And in that littleness, we are vast. So what do we do now? We build, we prepare, we watch again, and we ask better questions, not only of the sky, but of ourselves. Because one day, another object will come, maybe next year, maybe in a century. It will pass quietly, or not. It will behave strangely, or not. But we will be ready to ask not just what it is, but what it means, not just to science, but to story, to silence, to time. In the end, perhaps the meaning of the silent follower is not scientific at all. Perhaps it is existential, a whisper that we are not at the center of the universe, but we are on the edge of something large, something cold, something watching. And when we looked up and saw it move and named it, we passed the test. We noticed. And in a cosmos filled with noise, that noticing may be the most important act of all.